Today we are going to finish the notes that we've been working on the past 2 days. So we are in the 6th set of notes dividing polynomials on the back of the first page. So now we're going to take the skill of synthetic division and actually apply it to problems how you would see it on the PARCC. So notice the directions say divide using synthetic division and find an expression in terms of A that represents the remainder. So after all is said and done, they want you to highlight what the remainder is. So just like before, we figure out what is the value that goes in the box. So to figure that out, I would set this equal to 0. I'd add A over, so x equals A. So the value that's going to go in the box is a positive A. So I have a positive A in my box. And now I list my coefficients. So I have 1x squared, I have a negative 7x, and I have a positive 4. And we do the whole process of multiplying, adding, multiplying, adding. So I drop my 1, and I multiply. So A times 1 is A. Now, when I go to add, these are not like terms, so I can't actually add them together. So I'm just going to have an A minus 7. And now when I multiply these together, A times A is A squared minus 7A. And now we combine like terms if we can. I'm just adding, so this will be A squared minus 7A plus 4. So that's all they want you to do, and they want you to highlight what the remainder is. So our answer would be this A squared minus 7A plus 4 over the x minus A. So that would be our remainder. I don't need this other piece because they just wanted you to highlight what the remainder was. So that's letter A. We're going to skip letter B and C, save those for tomorrow. I'm going to show you letter D. So letter D is a little different in the fact that you know what I'm dividing by. If I set this equal to 0, x equals a positive 1. So in my box is a positive 1. What's different this time is the coefficients. They are variables. So I have k squared for my x cubed term. So that's my first coefficient. Or sorry, for my x cubed term. For my x squared term, I have minus 2k. Notice I don't have an x term, so I'm going to put a 0 for a placeholder. And then I have minus 7. And we're going to do the whole thing that we did before again, highlighting what the remainder is. So I drop my k squared. And 1 times k squared will give me k squared. And when I add these, I get k squared minus 2k. And I do that process of multiply, add. So 1 times k squared is still k squared. 1 times minus 2k is minus 2k. So add these, k squared minus 2k. So again, multiply and then add. So I have k squared minus 2k. When I add these together, I get k squared minus 2k minus 7. So my remainder is k squared minus 2k minus 7 over this x minus 1. So that would be an expression that represents our remainder. So this is just highlighting the remainder. So the next two examples that we're going to go over is, okay, once we've figured out that expression for the remainder, we are going to force it to be 0 so that way I don't have a remainder. So it says determine A such that x minus A is a factor. So that means once we find the expression for our remainder, we're going to set it equal to 0 and figure out, okay, well, what value would work so that I would not have a remainder. So the value that is going in our box is a positive A. Since if I set that equal to 0 and solved, it's a positive A. I have 1x squared minus 6x and a positive 8. So I'm going to drop this down. 1 times A is A. And that means I have an A minus 6 here. And now if I multiply these together, I have A squared minus 6A. And if I add, I have A squared minus 6A plus 8. Now I'm going to pull that off to the side because now I want to figure out, okay, well, if I don't want a remainder, I need to see what this would, if I set this equal to 0, what values would I get for A so that I could work it and I won't have a remainder. So this is factoring. So the combination that multiplies to be 8 and adds to be negative 6 is a negative 4 and a negative 2. So I have an A squared minus 4a minus 2a plus 8, and we group. I can take out an a here, and I'm left with a minus 4. I could take out a negative 2 and an a minus 4. So I have a minus 2 and a minus 4. And if these are both set equal to 0, the two answers that I get are positive 2 and a positive 4. So if I go back and fill these in to this x minus a binomial, if a is positive 2, that means I have an x minus 2. If a is positive 4, that means I have an x minus 4. So either one of these quantities would be a factor, since they would not give me a remainder. So it's the same thing that we did before. The only thing that's different is that I set the remainder equal to 0 and actually solved it. So one more like that, just slightly different. So again, I'm doing the box with a 1. Since x minus 1 set that equal to 0, I get a positive 1. So I have k squared x cubes. I have no x squareds, so I need a placeholder. I have minus 6k for my x, and a 9. So again, we're going to do all this and figure out what the expression is for the remainder, and then we're going to solve it at the end to figure out what is the value that would make it perfectly divisible, meaning no remainder. So if I drop this k squared down, we have k squared here. K squared times 1 is k squared. K squared plus 0 is 0, or is k squared, sorry. 1 times k squared is k squared. If I add these, we'll have k squared minus 6k. Multiply 1 times that, it'll keep it the same. And then we add those two straight down. So we have k squared minus 6k plus 9. So the goal is we're now going to take this expression and set it equal to 0 so that I can solve. So I'm going to switch screens so I have more room. So I have k squared minus 6k plus 9 equal to 0. So my two values that multiply to be 9 that add to be negative 6 are negative 3 and negative 3. I'm going to do the box this time. You don't have to do the box, you can do your grouping way. So I have k squared minus 3k minus 3k and a 9. We figure out what we can take out. So the first column I can take out a k, first row I can take out a k, second column a negative 3 and a negative 3. So I have k minus 3 and a k minus 3. So if I set these both equal to 0, I get the answer of k equals 3 both times. So the value that would work is, when my coefficient is 3, it would be perfectly divisible. So that's all for today. We're going to completely finish the rest of these notes for tomorrow.